So, good morning, everyone. It's me again. Today, I'll guide you through the process of understanding the CORELAP algorithm. So, let's get into the video. Now, what's the point? I have talked about this in my last video, but I'll say it again. So, imagine when you have a building, right? Imagine you are a business owner and you have 10 different departments. So, now, how should you organize the department in a way that optimize the whole company? So for example, here, you will want to optimize the department in a way that maximize maybe communication flow or personnel flow or material flow, sort of that thing. So yeah, that's the point of this algorithm. Just imagine. So do you play Tetris? Just imagine the department or the bricks you are seeing on the screen, and you are trying to fit them in a um, order that makes sense and in the most optimal way. Now, compared to our depth algorithm, here we only have two parts, two steps. First is department selection, and then department placement. So in department selection, you will figure out the order. So which department to consider first and second and third and so on. And for the second step, you will start to place the department in the building. So now here are all of the rules. They are a little bit confusing. So I'll tell you more when we dive into the example. It will be more understandable. So let's talk about an example. So here we have 9 different departments, right? So receiving, shipping, and so on. And we have the relationship here. If you still don't know how to read this relationship diagram, I'll show you. For example, we have the A here, right? We look at its diagonal direction. So here we trace back. Oh, so it's related to department 3 and department number 5. So between department 3 and department number 5, these two departments have an A relationship. Okay. So the same here, trace back to number 3 and number 8. So that's how we read the relationship diagram. Now, we have the score here for each of the relationship. You can set this score uh, how 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 many ever you want, as you seem fit. So I'll just set it randomly as this number. Now, after we are given the relationship matrix, this triangle here, we will construct the TCR table on the right hand side here. So yeah, now here let's take an example. So this E, why is this E? So it's the relationship between department 4 and department 3. Let's trace it back here. 3, yeah, 3 and 4, their relationship is E. So the same is for 3 and 4. It is the same, right? So this table is basically um, the upper part of the diagonal line on this table is the mirror of the lower part. So here they reflect off each other, as you can see. Yeah. So that's it. We done with the department relationship part. Let's move to the next part. Summary. So what does this part mean? So you just count the number of relationship on each row. So for example, look at row number 1 here. How many A's do we have? 1, 2, 3. So we write in here 3 A's. How many O? 1, 2, 2 O's, and so on. So the summary part here is very easy. You just count the number of A, E, I, O, U, X relationship in the department relationship part. That's it. Very simple. So now, we have to calculate the TCR. It means total closeness rate. So how the hell do we calculate this number? That's we will base this score based on the relationship score we are given at the beginning. So how do we achieve this number 402 right here? How? Let me show you. So you look at the summary part for row number one, right? So you have three A's. So 3A, right? 3A, 1E, 2O, and 2U, right? So what is the score for A? 125, right? E is 125, 2O, right? O is 1, and 2U is 0. So you sum all these things up and you will receive 402. That's all. This is how you calculate the score. Okay. And these numbers, you will look at the summary column of the table and the score is given right here. That's it. It's that easy. And you repeat the process for other department. Now, we have the TCR value. We have the placement sequence left. It is the last thing we haven't finished yet. So how do we figure out the placement sequence? Do you remember the rules? I say that they are confusing and I'll talk about them in the example. Now I'll tell you. So I have the rules on the right hand side, as you can see. Now I'll guide you through the process. So look at step number one. Look at step number one. Um, we will choose the first department with the highest TCR value. Highest TCR value, okay? So look here, TCR value. Which one is the highest TCR value? 625, right? So it is department number 7, okay? So we will choose the department number 7 as number 1, as the first one, okay? There's no time here. 625 is the highest TCR. Now, let's move to the second step. If a department has an X relationship with the first one, which is uh, department number 7, we will place it last in the layout. So do we have any X relationship with department number 7? Look at row. Oh, so department number 8 has a X relationship with department number 7. So we will place department number 8 last, okay, in the layout. According to step number 2, there is no tie exists. There's only one department that has an X relationship with department number 7. So we will place department number 8 last, which is number 9, right? This is the order of the department, okay? Now, we choose the second department. We will choose the one with an A relationship with the first one. The first one here is department number 7, right? So we have 3 departments that have an A relationship with the 7, with department 7. If a tie exists, choose the one with the greatest TCR value. Now, number 5, number 6, and number 9. Which one is the highest? Let's see. 5, 6, and 9. So 527 is the highest TCR value among these 3 values. So we choose department number 5 as our second department. Let's see. If a step 4, okay. If a department has an X relationship with the second one is placed next to the last. Okay, let's look at department number 5. Do we have any department that has an X relationship with department number 5? Look at the row. No. So we skip step 4, okay? we move to step 5. The next department is the one with an A relationship with the already placed departments. Okay, so this is the key difference between CORELAP and OutDep. So in CORELAP, you will assess the next department based on the relationship with the already placed department, not the latest placed department. So you will consider the relationship of department 2 and 1 to other department, not just, sorry. So you will consider the relationship of the third department with department number 5 and 7, not just department number 5, which is the latest placed department. So now let's see if we have any A relationship, department that have an A relationship with number 5 and number 7. So here we have a lot of A. Okay, so we have department 3, department 3, department 4, department 5 has already been chosen, department 6, 7 has already chosen, and department 9. Okay, so now we have 4 candidates. We have a tie. Again, we will look at the department which has the greatest TCR value. 3, 4, 6, and 9, right? 3, 4, 6, and 9. So clearly 502 is the highest TCR value. So the winner is department number 9. Okay, so department number 9 will be the third department to be chosen. Yeah. Okay. So the process just continue again and again and again until all the department has already been placed. So I'll do one more for you. Now we look at department number 9, right? If a department, we back to step number 2, we look for any X relationship. So department number 9 has an X relationship with the department number 8. So we will put the department number 8 last in the layout and not consider, but we already put it last at the previous step, so we don't need to repeat that again. So now we move next to step number 3, choose the one with an A relationship and so on. So I think you understand the idea here. Let me show you the answer. Wait a minute. So yeah, right here. This is the answer. Wait a minute. Yeah, right here. So after you repeat the process again and again and again, you will have this placement sequence. So 7, 5, 9. Let me check if we did it correctly. Oh, I erased it. Oh no, yeah, here. So department number 7 is the first one, as you see here. Then 5, and then 9, and 8 is the last. Are we correct? 7, 5, 9, 7, 5, 9, and 8. Yeah, 7, 5, 9, and 8. We did it correct, luckily. Okay, so now what do you do once you have this placement sequence? So we move to step number 2. Okay, department placement. We will consider the department neighbors. So what the hell does that mean? I want you to understand these two new concepts. So consider department 0. It has how many? It has 8 neighbors department, right? But they are different. The adjacent department are 1, 3, 5, and 7. So the word adjacent here is just a fancy word for next to. So how do we know if a department is adjacent to department 0? So we know by seeing, oh, if there are any shared edges. Okay, so here, for example, department number 0 share an edges here with department number 1. So the department number 1 is adjacent to department 0. Okay, so how about 8, 6, and 2 and 4? They are just touching department number 0. Why? Because they only share a corner, a point, a corner, not the entire edge. You get me? So adjacent, you share the entire edge, but for the touching neighbor, you only share a corner, a point on the corner, okay? And then we calculate the placing rating. It looks kind of intimidating, so I'll tell you in the example. So these again are all of the rules. So it will get a little bit confusing. Let me show you through the example. Okay. So here, now we have the free step right here, right? The free step for department placements. The first department selected is placed in the middle. So how do we know which is the first department? We look back at the department placements sequence. We have in step 1, which is right here, as you can see, okay? So we will put department 7 first into the layout. Then we will evaluate the PR, which is the placement rate for all possible location. We will count all of these score, okay? But how do we calculate the score right here? Why the hell do we have like these number? So let me show you a little bit. Wait a minute. Okay, so the first department to put into the building is department 7, then department number 5, right? So where do we put department number 5 in this 8 point? Should we put it here, here, or here? Where should I put it? So before you put department number 5 down, you have to calculate the score. How do we calculate the score? So what is, we have to first consider what is the relationship between department number 5 and department number 7. What is their relationship? 5 and 7, their relationship is a relationship, okay? Their their relationship is an A relationship. So we have A right here, which is 125 point. For the for the position that is adjacent to department number 7, you will receive a point of 125 if you put number 5 here. Okay. Remember the definition of adjacent department, which are the department that share an edge, right? So why are these 62.5? Because they are the touching department. For the touching department, you will have to take this point and multiply by 0.5. So the point is cut in half for the touching department. Okay, so that's why we have this number. So we will choose to place department number 5 at the place that has the highest PR score. So we should place department number 5 at these 4 places. But which one of these 4? So you look at the rule here. Um, in counterclockwise order, beginning at the western edge. So the western edge of department number 7 is this guy. That's why we place department 5 number here. All right. Okay. So I think you get the idea. So now, after we have these two guys placed down, we will start to consider department number 9. So where do we how do we calculate the score? Once again, you will see the relationship between 9 and 5, 9 and 7. Okay. Mm, let's see. 9 and 5. 9 and 5 is A. 9 and 7 is also A. So department number 9 has relationship A with both of department number 5 and 7. Okay, so how the hell do we get all these scores again? Let me show you. 62.5. Why do we have this score? So if we place department 9 number right here, right? It has an A relationship with department number 5, but this position is only a touching position. So we have to cut 125 in half, which is 62.5. Okay, that's easy. Next, why is this 125? Because this position is the adjacent position to department number 5. So it keeps all of the score of the relationship A. Okay, understand? Now, here's the tricky part. Why the hell is this 187.5? Huh, you ask. So the reason we have this point is because this position share the edge with department number 5, right? So it's 125. But this position is also the touching position of department number 7. So we have to um, also count this in, which is 62.5. This is why you have the score of 187.5. So I'll say it again. This position is adjacent to department number 5, and it is at the same time touching the department number 7. Okay. So now we have these 4 highest points. Where should we put the department number 9? Again, you have to look at the rules counterclockwise, beginning at the western edge. Okay, the western sorry, the western edge is right here, right? And we will move counterclockwise, which is this direction. So not this one, not this one, this one. So we will place department number 9 right here. Let me check the answer for you. Okay. Okay, correct. We place department number 9 right below department number 5. And you just move on. You just continue this process on and on and on. You count the score, and then you see which score is the highest, and you put the department in that place. Again and again and again and again. So as you can see here, I'll just tell you a little bit about this. Why do we have this negative number here? It is because of the x relationship. That's fine. Negative number are okay. Don't worry. So you will receive a final layout like this after you complete the step number 2. Okay, so that's all. So some of the comments about this algorithm is that the layout often result in a very irregular building shape. So for example here, so this is still a normal layout, not that strange, right? So you can have a building that looks like this, but sometimes the shape is very strange and weird. So don't worry, it's a feature of this algorithm. It's not a bug. And this CORELAP algorithm, it attempts to produce the most optimal layout, while the algorithm we learned from 2 weeks ago, it tries to produce many layouts as possible for you to evaluate between them. But CoreLap, it attempts to produce the best possible layout for you already. Okay. So that's all for the CoreLap algorithm. Again, ask me any question in the comments. I'll try to explain it to you. And maybe the next video will be about the graph algorithm. Okay, it will be a little bit trickier than CoreLab and RDEP, but I'll try. So, if there are any points in the video that you find difficult to understand, just comment in the, the comment section below. I'll try to answer your question as many as possible. Thank you for watching. Goodbye.